Hello, everyone. Welcome to the TIBCO Analytics Meetup. My name is Helene Snelting, Director Data Science at TIBCO. I'm here with Adam Vaskovic. He's our lead data scientist in the TIBCO Data Science team, and Neil Kanungo, Senior Data Science Manager and also known as Dr. Spotfire. We're missing Michael O'Connell today. He had a conflict that sometimes happens with live events, but he sends his regards and will be there next TIBCO Analytics Meetup. So the confidentiality disclaimer, just to say that everything that we share with you today is for informational purposes only. And then the agenda. So we're going to be talking about sports analytics today. As you know, with the TIBCO Analytics Meetup, we always show our latest AI app or the latest application that we've built. And this time, Adam will be demonstrating his pro basketball draft analyzer that he created and is available on the TIBCO community. But we'll start off first with a bit of background on sports analytics. And I will wrap up with some TIBCO community resources because we have a new TIBCO community that we'd like to show to you. And actually throughout the session will be available to answer questions. So just post them in the comments, and Neil will pull them up and we'll try to answer them during the session or at the end. I'd like to share on the next slide some resources for you to know when these events happen. We're simplifying everything a little bit with our community events. So on community.tibco.com, which is our main community site, we're posting all of these community events. So the TIBCO Analytics Meetup, the Dr. Data Science and Dr. Spotfire sessions, they'll all be there. If you look at the red arrow with these little red calendar tiles. So if you click on one of those, you'll find a link to join. You no longer need to register. You can just join these live sessions as you are today. The way to find out that they're happening is either you bookmark this community site. You can also join our LinkedIn groups, either for data science or for Spotfire or both, depending on what you're interested in. And you'll be notified when the next session is up. And if you prefer to email, you can also email us at askdataScience@tibco.com. And with that, I'd like to hand over to Adam to give us a bit of a background on sports analytics.
Yep, thanks, Helene. So today what we're going to be talking about is sports analytics, and I'm going to start at the beginning of sports analytics and how it has come up over the years. So the first bullet that I have here is for SABR, the Society for American Baseball Research, which was established in 1971. And this actually was the root of the term sabermetrics, which generally refers to sports analytics. It actually got its root with this organization. And it was basically the first formalization of baseball analytics becoming part of a group and being a lot more serious. And one of its most prominent members is Bill James, who, because of his work as, you could say, the godfather of baseball analytics, was named to the Times Top 100 Most Influential People in 2006. He ended up becoming a consultant for the Red Sox and had a lot of success in doing so. Now, what a lot of people think of when they think of sports analytics is Moneyball. And this was a book that was put out by Michael Lewis in 2003, which later became a movie starring Brad Pitt, that documented the Oakland A's and the GM, Billy Beane, their success while focusing on sports analytics due to their very low payroll. They had like $100 million less dollars than some of their other teams in the league. So they had to find specific undervalued statistics that they would emphasize and make a key point of their strategy. And they were very successful in doing this and actually then paved the way for many other teams to follow. So one of the examples was the Red Sox, who did get Bill James and became a lot more analytically minded and won several World Series doing so. Now, up to today, sports analytics has really gotten very, very big. There's now the MIT Sloan Conference. It started in 2006, but it's sports analytics conference, and it's the largest student-run conference in the world. And it has representatives from over 80 different teams who want to hear about the latest and greatest in sports analytics. Now, there are kind of three recent advancements that are kind of key in recent years, and this is the improved data collection. There are more sophisticated algorithms available, and there's also now integration with coaching and scouting. So if we move on to the next slide, we can kind of see how this cultural shift has happened in a lot of the pro sports. So starting with baseball, and this is actually a theme across many other sports, is that there are camera and radar systems installed at every stadium. And this actually started the beginning of the quote unquote StatCast era of baseball. So baseball is kind of divided into different statistical eras. There's now the StatCast era because of all these cameras and radar systems, which makes a lot more advanced statistics readily available. And with those statistics, teams have now changed their strategy. And this is actually where the popularization of the shift came about. So the shift is where, if we look at the image on the right, there are typically 4 infielders that are defending in baseball, and they're typically like equidistant away from one another. There's a couple on the corners, and then there's 2 up the middle. But what the shift did is it said, well, if the hitter only hits it to the left side 16% of the time, then I want to move all of my infielders to where he does hit the ball. And this ended up being extremely successful. It's a very frustrating for hitters, and has now even, I think, starting this year, has been banned in some sense because it gave too much of an advantage. And then in other sports, with the NBA, we have a lot more 3-pointers that are taking place. We averaged 18 3-pointer attempts per game per team in 2012, up to 27 in 2017, and that number, I figure, is definitely only going up. They are also definitely benefiting from the tracking and video technology, this key in scouting, also injury prevention. You'll see a lot of players who take days off every now and then if they're kind of older. I know this is a frustration for many fans because they want to see LeBron James play, but you never know if he's going to sit out because the analytics say that he needs to rest. So that's a new thing that's happened in the NBA. And then in the NFL, basically a lot of key decision making has been made with analytics. So whether the team goes for it on 4th down, for example, there's now just probabilities of, if I make that decision, what's my probability to win the game if I do so. So a lot of analytically minded coaches will defer to the analytics in this sense. And then in soccer, we just have points like where strikers are shooting less frequently from a distance. It's kind of changing the way that the game is going just in certain senses. But now if we just move on to this next slide, I can kind of go to one of the points that I was talking about earlier, which are the improved data collection. And the way this is happening is through cloud partnerships. So each of the big pro major sports has these partnerships with these cloud vendors. So we have the NFL with AWS, we have Azure with the NBA, Google Cloud with the MLB, and Oracle Cloud with the Premier League. And it's basically kind of this mutually beneficial arrangement where these cloud vendors will store, all of this data from all of these camera, radar systems, and they'll help develop some advanced statistics. And these will be available to teams to do some more analytically minded, strategy, scouting, things like that. And it's also making a lot more data-driven product out for the consumer. So see in the top left, cool charts are being put out of what the running back, all of his runs looked like in a certain game. And this is actually even happening. Amazon Prime just got the rights for Thursday Night Football, and they make a pretty data-driven broadcast. So they are, definitely show off these next-gen stats, and it makes for a lot more forward-thinking, analytically minded broadcasts. So, and I figure that's only going to get a lot more analytical from here. So now we're going to take a look at just some TIBCO examples of us using sports analytics in a few different areas.
Yeah, and I was just going to talk a bit about TIBCO's partnerships and some of the work we've done with sports analytics. So TIBCO does have a partnership with Mercedes F1, and we do some really interesting work with Mercedes. We have some R&D testing where we look at the wind tunnel testing complemented with TIBCO analytics to actually influence the design, engine performance, and component reliability of the race car. We've done a cost management and regulatory compliance analysis. This cost visualization tool helps the engineering, finance, and operation teams collaborate together on how their spend is and gives them greater understanding of the control of their expenses. And we've done some digital twins simulations and strategies as well. This helps determine optimal overtakes, gear changes, braking, strategies for each individual racetrack, and data available from the track and car and driver. So a lot of different angles are being used with our analytics with Mercedes F1 in that partnership. And Helene, if you want to talk about the TIBCO SVB cycling partnership that we have.
Happy to. Yeah, the EF Education TIBCO SVB cycling team is the longest running North American women's professional cycling team. And we've been working with them for a while. As Adam mentioned, analytics are used to engage fans more as well. So we created this dashboard, which is available on the demo gallery actually for Spotfire. It's a dashboard that shows the biggest races that this team raced in. And what's unique about it is that it's showing the whole team. So you can actually look at the race strategy that they developed for the race and how they executed it. Because even though there's always one winner, it's really a team sport. So this way you can look at the data and see how they sort of help each other out in the beginning with some people riding on at the front and sort of using most energy and power to get the rest of the team up the mountains. This was a 125K long race in Spain in May this year. And Veronica Ewers actually won the race, but it was partly because she was helped by the rest of her team at the beginning of the race. So looking at the data from the bicycles and from their body monitoring equipment, such as heart rate, but also power metrics from their pedals, GPS data, we can generate some really interesting analytics. And at the moment, we're also working with their performance director to also include some of their training data from Training Peaks to see, how they can make better recommendations to be best at their races.
We also have a dashboard on our demo gallery on Roger Craig for Hall of Fame. This compares Roger Craig to other running backs in the league and other running backs that have made the Hall of Fame and those that have not made the Hall of Fame. And it's a great visual analysis of Roger's performance over his career with some interesting visualizations. There's several pages and different angles that we look at of Roger's performance over his career. So that's worth checking out. And every March we do a March Madness predictor. And this is a matchup predictor where you can select two teams and it runs a statistical workflow that actually predicts with really good results, predicts which team will win. And it looks at different metrics such as Jeff Sagarin's rating, Sonny Moore ratings, defensive team metrics, basketball power index, offensive metrics, number of top 25 teams that each team has beat, and the travel distance for fans to get to the game. So you have a sense of how many fans are going to be, if it's going to be kind of more of a home or away situation for each team. So this has been, this has placed us in the top, I believe, 98th percentile of ESPN brackets each year. So it's been a lot of fun doing that. And that's also available in the demo gallery. And then Adam's done a really cool analysis on MLB outlier pitches using the local outlier factor. Adam, did you want to talk a little bit about how this works and some of the results that you've seen?
Yeah, sure. So this was a data function that we actually put out. You can find this in the community. It's the local outlier factor data function. And it's an anomaly detection method. And I just used the algorithm on some baseball statistics that I was able to get. And so basically the intention was to see, well, what pitches that we've seen are outliers. And we then created a page that made it so that you can click on what was found to be an outlier, and then you could actually view the video. On the video here, if you look at the top left, it pointed out a very strange pitch. So this is Tyler Rogers. He basically throws, unlike any other pitcher in the league, he throws at like the bottom of himself, and it makes for a very hard time for the hitter to hit it. But it was good to see that this algorithm did pick up that his pitch is definitely one of the more outlier-ish of others.
So with that, Adam, do you want to lead us in a demonstration of the NBA draft analyzer and scouting pick?
Yep, sounds good. So if we go to the next slide, I can just give a quick summary. So what we're going to be taking a look at today is essentially a tool that we've developed that can help coaches and front offices be able to analyze the upcoming prospects in the NBA draft. So this tool helps you look at player profiles, see what the strengths and weaknesses are of some of the players in the draft, also allows us to compare them to modern NBA players. We do so with a statistical method called principal component analysis. Makes for a very cool interactive dashboard. So with that, I will start presenting. Okay, cool. Do we see my screen?
We do.
Oh,
Well, now we see Google.
now we see Google.
Yeah, there we go. We see your
Yeah,
screen.
cool. All right. So what you're taking a look at is this first page, which is our player profile page. So this shows the top 10 projected picks in the NBA draft and allows us to just explore and learn a little bit more about these players. So the first player that we're looking at is Paolo Banchero. And what we see here on the left is that here are some of his top statistics with 2-pointers, 2-point attempts, field goals. And what we're looking at are the percentiles for how well he's done compared to the rest of the college players in our data set. And we see that he's very well-rounded. He has good offensive, defensive, and neutral statistics. And then we can see all of the statistics here and where he ranks in this middle chart. Now, what's particularly interesting, though, is this top right bar chart. And what this looks at is the players that are most similar to Paolo Banchero. And the way that we did this is we took what is a data set of college statistics dating back, I think, to the 1990s. And we're looking at the college statistics of current NBA players and these prospects. So we basically wanted to put it apples to apples. So let's compare Paolo's college stats with, for example, Jason Tatum's college stats. And maybe if they're similar, that could say something about the player that Paolo might become. So, and that actually did show up. So Jason Tatum ended up being in the top 10 most similar to Paolo. The most similar was actually Luol Deng, another good player, and Tobias Harris shows up. So what you want to see here for the prospect is gold. So gold is this star power measure that indicates how well these NBA players have done in the NBA. So, you know, we're comparing them on college statistics, but we have the retrospect to now say, well, these players actually did pan out well. So you'd want Paolo to look like them. So, and then on the bottom right, we have this very cool spider plot. So this is an example of the Spotfire mod. So these are visualizations that we can actually bring into Spotfire that were custom made. And they're very cool here. So we can kind of see the shape of what Paolo's statistical profile looks like. So, you know, we're taking a look at just some of the percentage statistics in our data set. So things like his 3-point percentage, his assist percentage, block percentage, etc. And we see that him and the similar players to him kind of have this similar shape. But if I move on to the next player, which is in this case Chet Holmgren, we can see how the rest of the dashboard changes. So we see immediately top statistics. He's 99th percentile in many, many statistics. He was very good in college. He's, you know, very good at blocking. He's very tall, lanky. So he has a very good defensive game, which we see with this rose chart, which is also a Spotfire mod. And then the thing to point out here is that the top right also has a lot of gold. So we see that he's close to Karl Anthony Towns and a number of other, you know, good quality players in the NBA. We also see that his shape does change as well. Definitely looks a lot different than Paolo's did, with some very high percentiles at some statistics. Now, the next player that I'll look at is Jabari Smith Jr. Just what I want to point out here is that he also has a lot of gold and a lot of very good comparisons. So we have Brandon Ingram, Bradley Beal, Jason Tatum as his top 3. Those are all very good players. And the reason why I want to say that is that I'll move on now to the 4th player in this draft, which ended up being Jaden Ivey. And the thing about him is that he actually has a lot of white on his bar chart. So rather than gold and having good comparisons, he actually had a lot of comparisons to players that didn't pan out well in the NBA. And what's also interesting about this is that going into draft night in the 2022 NBA draft, they didn't know who was going to be the first overall pick. It could have been any of Paolo, Chet, or Jabari Smith Jr. And typically they know going into a draft, there's usually one player that separates themselves, but they didn't. So each of these players does look good when we're looking at their profile here. But then we see there's a big drop off when it comes to Jaden Ivey. There's a lot of white here. And maybe that says something. I think it's cool to see that, our methods did agree in some sense with the NBA draft analysts. Now, I'll also make the note that this doesn't mean that Jaden Ivey is not a good player. All we can do is help give information to decision makers to help make the most informed decisions possible when deciding who to draft. Now, nothing is set in stone. Sports can be very unpredictable, but we're just kind of trying to create a tool that can help give the analytical minded staff at least some sort of edge. So the next thing that I'll take a look at here is a correlation analysis for our data set. So our data has around 38 statistics in it for those college stats. We have a ton of variables, but what we're going to do is dimensionality reduction using principal component analysis. And the reason why is I'll show you here. So I'm going to raise up a correlation here, or raise up a filter when looking at correlations in our data set. So I raised this to 0.72. And what we're looking at here are very statistically correlated variables. So we see kind of these groups of variables emerge that are very interconnected with one another. So we have like assist percentage, we have effective field goal percentage, true shooting percentage, so kind of some shooting percentage statistics here. And what PCA is going to do is it's going to recognize kind of these groups of statistics, and it's going to lower the amount of variables needed to carry that same information. So, and why this is going to be valuable is it'll help us do this distance metric that we're going to calculate on the players in the future, but it helps get rid of this redundant information. We don't need all 38 variables. And then in a sense, keeping all 38 variables, especially if they're correlated with one another, will kind of introduce noise where it doesn't really matter if someone's true shooting percentage or 2-point percentage differs a bit. It just matters in general how good of a shooter they might be.
And Adam, can you zoom in a little bit on that network chart? It's just a little unfortunate. The fonts are a little small. We're aware of that on this broadcast, but you can
see it a little bit better now.
Yeah, we can see it better now for sure.
Yeah, cool. So, we see like around, let's see, like 7 groups, pop up here, all just with these very interrelated things. So, if on this right one here, we have defensive rebounds, offensive rebounds, total rebounds, and total rebound percentage. So it makes sense that these are very correlated with one another. If a player has a lot of offensive rebounds, they're more likely to have a lot of defensive rebounds. So when we're making these comparisons between players, we don't need all this information to be carried and stored. So that's why we do PCA. So now I'll move on to our more technical deep dive of a page. So I'll start off with explaining what's happening with this PCA principal component analysis. So like I said, we start off with around 38 variables in our data set. But what PCA is going to do is it's going to summarize the data through these principal components. And just using the first 2 principal components, we capture 50% of the information in the data set. So just those 2 says a lot about a player compared to having to keep all 38 variables. And then when we do our distance metric later, we can keep around, I think, 11 principal components, which captures around 90% of the information of our data set. But we see at a certain point, we start to get these diminishing returns where adding more variables here isn't really worthwhile and doesn't really add too much information. So we'll keep around 11. But the first thing that I'll look at here, though, is we'll take a look at those two principal components that contain 50% of the information. So that's what we're looking at here with the scatter plot in the middle. And so this is plotting principal component 1 versus principal component 2. This is all of the players in our data set, and they're colored here by their success measures. So Gray are the players that ended up being bad in the NBA. This kind of faint yellow are good players. Gold are star players, and then red are our prospects. So what immediately pops out to me is that on the left side, we have a lot of stars. There's certainly a lot more stars when principal component 1 is negative compared to the right side. And then the next thing that I do is just kind of look at, well, who are these players that are on an island, these stars? And when you take a look at it, I see Steph Curry and Trae Young at the very top. And this makes a good deal of sense. So these are two extremely good shooters. Steph Curry will probably go down as the best shooter of all time. So it was good to see that they were at the very top. And then the next question that I had for myself is, well, who are the stars then on the bottom? And if I look on the bottom, who I see are Joel Embiid, John Collins, Derek Favors. So these are your 7-foot big men, your massive people who block a lot of shots, play a lot of good defense, make a lot of shots. And it was kind of cool to see that this is what the output of principal component analysis gave us. It kind of gave us, a composite statistic that, when it's very high is more of a shooter, more of kind of a point guard type player, whereas the very bottom is your center and your blockers and people who get rebounds. And we can actually even explore what contributes to a certain variable as well. So right here, we're looking at the component weights for all the different statistics. So like I was pointing out before, so this is principal component 2. And for things like 3-pointer, 3-point percentage, it's very, very positive. Assist percentage. So that basically shifts that principal component up if they have good 3-point measures, 3-point percentage, things like that. But then when it comes to block percentage, that lowers that statistic. And this kind of makes sense based off what I was saying. So a lot of blocks for big men, a lot of shooting measures for those that are on top. So kind of cool that you can still at least see what the definitions of these components are. Now, after doing principal component analysis and doing dimensionality reduction, what we're going to do is something that's very simple but is very powerful, and that's just doing a whole distance matrix of all the players in our data set. So here what we have is every single player as a row, and then every single player is a column. And the numbers that we see here are just the Euclidean distance measured between the statistics of the principal components. So those 10 principal components, if we just calculate the distance, we can get some sense of how similar one player is to one another. So when doing that, we were able to get those similarity measures on the last page, and we can also then look at any player here in our data set. So I'll actually click here on this one star who's also on their own island. So this is Kevin Durant. Interesting to see the most similar player to Kevin Durant was actually Carmelo Anthony. He has the smallest distance measure when looking at all the principal components. But another cool thing that I saw that came up was that Paolo Banchero was actually in his top 10 most similar. So that's another good thing to say about Paolo Banchero's game, is that Kevin Durant is also pretty similar to him. So that's pretty cool. So that is, basically wraps up my demo. I basically wanted to show how we could create this very interactive dashboard that allows, coaches, decision makers to just learn more about their players. And this is all done using just, Spotfire visualizations, mods. We use a principal component analysis data function that's available to you today if you go out and download it. And then it's very simple to just set up the data function to be able to, make this analysis yourself. So thank you. And I'll now turn it back over to,
Yeah. So we actually have a few questions.
Oh, yeah.
So Filippo has a couple questions. One, anything showing soccer data, visualizations with scatter plots on a pitch as a background, a shot map, or goals on target. I think that a soccer analysis would be really appropriate right now with the World Cup going on. But we don't have one for this World Cup. There is a soccer analysis, I believe. You can find it on the community with the last World Cup, right, Elaine?
Yes, yeah, there is a World Cup prediction analysis on the community. I'll show a few resources later. We're always happy for people to
Yeah, and then
contribute.
in addition to that, we have done some pretty cool football analysis actually, where we actually have done something where we overlay the shots, all different types of events that happen on a pitch. And we actually use a pretty similar analysis for that type of football data, just doing this same process of doing principal component analysis and then doing these distance measures. That, that same process could be abstracted out into all different types of use cases. It actually generalizes very well.
Filippo was also asking about a little bit on building the dashboard. Can you detail anything about the elements, the visualizations, the mods, the distance measure? I know you use the distance measure data function there and use the PCA data function. Do you want to show a little bit about how that works?
Yeah. So basically, when we were kind of designing how this looked, I think on this page, kind of just playing out with different types of mods kind of led to interesting, looking at the rows chart and seeing offensive, defensive. I think this ended up being a very nice way. So I think that at a certain point, I was just exploring with the mods to see if I could find anything that was pretty cool. In addition to this, spider plot is something that's kind of often used in sports. You kind of see it a lot in sports video games like FIFA. You'll see that the strengths are kind of put out into these spider plots. So it's kind of a cool use of that there. And then a lot of this, though, like in terms of the analytics, like you were mentioning, was enabled using data functions. And I'm viewing this from the web player, so I can't open up those data functions now, but it's using that principal component analysis data function, using just a simple distance matrix data function. That was only a few lines of code that help us, enable this whole thing.
Do you want to switch over and show the data function flyout? We can give you a second to switch over your screen.
Yeah, let me do that.
And then, important note about like those spider plots and principal components and the kind of profiling of the players. So the principal components is taking all of those columns of data that Adam showed, and it's reducing it down to a couple dimensions. So we're able to reduce it down to principal component 1 and principal component 2. So visualizing just 2 dimensions rather than having all 30 something dimensions shown. But getting that same value out of all 30 something columns, 30, 40 columns, we're getting that same information out of it with just a couple components. And then when you're doing that spider plot, a tip is to put on your x-axis, you put all of your columns, and then on your y-axis, you put your column names. And you want to normalize your data from 0 to 1. And there's a Spotfire transformation in the data canvas that you can use to normalize your data from 0 to 1. I think Adam's statistics were already were already normalized, but if your data is not normalized, that's something you want to do.
Yep, definitely. Yeah, so I could show how we can, go ahead and build out, maybe I can show you how I can recreate this same scatter plot here, but just using the data functions. So using this FX flyout, we can take a look at some of like the pinned data functions that I have. So I just pinned here principal component analysis data function, and it's very simple to just set up. So if I just, change this, so it's asking for input data, what I'm going to do is take all of the numeric statistics in this college stats data. So I'll add them all here. I'll click OK. Now it's asking for the number of principal components. So I can hard code this and ask for a specific number of components, but here I'll do 0.9 because I just want the amount of components that'll lead to 90% of the explained variance. And then optionally, you can add in ID columns. I will here because I know that there's just a player column that I could add as an ID. And now I've made all the configurations and just very simple. So I can click this OK, and it'll run the data function, and it's already now completed. So I'll skip these recommendations for now. So, and I won't look at the data reconstructed, but that comes out with the data function. We also have that explained variance chart that I was showing earlier. That is a table that's outputted. but the data reduced contains actually all the principal components and the values. So I'll add these as columns to our college statistics just so we can visually recreate this and create some insights. So just on a new page now, I'll bring in a scatter plot. So bring in a scatter plot here, and I'll just make it between the first two principal components, which in this case, it's looking at this 0 column versus 1. And once I do that, we'll see that looks like the shape is pretty similar. So if I can just copy this over and we can kind of see how it might be looking the same. So I show a title bar. I'll just going to drag this over into our new page and we can see how we're going to replicate it. So if I now just need to change the colors of this, I'll apply the same color from the earlier visualization. And I can match it to those same values. And now I close out this legend. We can see that this is looking at the same data now. So we have the 2 stars that were on the top. This is the same as here on the bottom. So these are Trae Young and Steph Curry. And it's as simple as that to be able to run the principal component analysis. You saw that it literally just took a matter of seconds. So if you have numerical data and want to perform some dimensionality reduction, just go ahead and grab our PCA data function from the community, and it'll be very easy for you to get started.
Great. If anyone has any other questions, feel free to put them in the chat. I'm not seeing any other questions at the moment. So if we want to go ahead and close out with a little bit on the TIBCO community, Helene, do you want to say a few words?
Yes, let me do that. And I also wanted to say, Adam, really interesting to see you build that so quickly. I would imagine that this is very applicable to manufacturing, where you have a lot of different columns in your data, and you may just want to actually look at a few less parameters rather than tracking everything. Is this applicable to other industries as well?
Yeah, absolutely. I mean, this is really just like a nice demonstration of being able to use principal component analysis on sports, which is maybe a little bit more widely known, but this could go across all different industry use cases. I mean, yeah, manufacturing is definitely a great example because often you can have so many variables to deal with. So doing dimensionality reduction specifically with PCA is a really great tool. It's also a great way to visualize your data like I was just doing there.
Yeah, great. Yeah, I think sports is always good or people can relate to it. So it's a good way to explain these techniques, but it's very useful for lots of different industries. Yeah, let me just share a few pieces on the new community. So we relaunched the TIBCO community a few months ago. So the same content is there, improved, of course, but the same URL actually, community.tibco.com. And whenever we do these sessions, whether it's Dr. Spotfire, Dr. Data Science, or TIBCO Analytics Meetup, we always relate the content to something that is available on the community. So in this case, we created a sports analytics page that has all the resources available for you to look at that we talked about today. It's just opening up now. So we put all the different use cases there, links to the demos that you can go and play around with, but also to the data functions and the mods that Adam and Neil just talked about. So here's the cycling dashboard. Here's the basketball dashboard. So if you click on this link, which I'll do in a second, you go straight to the demo gallery. But also there's a community article that will help explaining the details. So if you go to the demo gallery, I mean, this is a good one to look at, the interactive demo gallery. There's lots of different examples there, and they're all linked to the cloud, where you can just play around with Spotfire without needing licenses. You can share this with others. So they can, and it's all interactive, so you can click around and just see how Spotfire works. So all those links are in there. So if you go to the sports analytics page, it will be easy for you to find everything. The other thing I wanted to point out is Spotfire Mods. So those were used today. Adam explained those, Neil as well. There are lots of resources on the community. I think the Spotfire Mods overview is a good way to start. This explains sort of what is available, a bit of background, and this is really if you want to use mods, just download them and put them in your dashboards. We also recently created a developer hub. So Neil and Jose in our team built that. So that's also available for you. So if you want to build Spotfire mods, this has all the information for you to know how to do that. The other thing I wanted to show was the data functions. We talked a lot about data functions today, so I just wanted to make sure that you know where to find them. We have an article that's called Data Functions Library, and there is a wealth of data functions there, which sort of explains, what they're used for, but also has the links to the community exchange, where you can download them with all the instructions for it as well. This is the exchange. And it's basically a place where you can get all these extensions to our products, and a lot of Spotfire extensions are available here. And the last thing I wanted to show is our AI on demand page. And this is really the content that this TIBCO Analytics Meetup is based on. So every time that we create a new, it's not showing the page. Oh, it's because I'm on the exchange, I think. Every time that we create a new application, we usually demonstrate it in these TIBCO Analytics meetups, and we store all that information here on the page AI on Demand, Data Science and Operations. And these are usually industry applications using one or more products, usually more products to really show the end-to-end analytics and data science lifecycle. So lots of examples here, lots of resources that you can look at. And if you have any questions, just use the community to ask a question. If you go to any pages, actually, you'll find a way to ask a question. If you'd like to contribute something, that's possible as well. So we hope that you will enjoy all the content on the TIBCO community, and let us know about the topics that you're really interested in, so we can cater to that in our community sessions. So with that, I think, Neil, we can wrap up. Thank you, Adam, for your great demo. Thanks, Neil, for all the organizing of the session and the information that you shared. And we look forward to seeing everyone in the next TIBCO Analytics Meetup.
I think you're muted, Neil.
Thanks, Helene and Adam, and thank you all for joining.
Yep, thank you.